Okay, now I'm going to show you two more algorithms for addition, the left to right algorithm and then one called the lattice algorithm. The left to right algorithm is adding without having to carry the 1, so it's actually a good precursor to just the standard algorithm. If you can get your kids to do it this way first, then carrying the 1 is kind of unnecessary. Like, it kind of takes care of itself in the problem. So let me show you how this works. Because it's the left to right algorithm, of course, we're going to go from left to right. So we're going to start, I know this seems strange because normally we start on the right side. We're going to go left to right, and it can be done. We're going to start here with the hundreds place. And we're going to add the 5 and the 7, but it's not really a 5 and a 7, it's a 500 and a 700. When you add those together, you get 1200. Then we go to the next one, 60 and 50. 60 and 50 is 110. And by doing it this way, we are carrying the 1s. They're getting carried just in a different way here. And then when we add our 1s, 8 plus 7, we get 15. And you notice we've lined them all up so they end at the same spot. And then you can just add straight down. You get a 5, a 2, a 3, and a 1. And it just happens to work out perfectly. And you don't actually have to carry the 1. So if that's a method that bothers students, this is a nice alternative. The good thing about this is you can also spin it around and you can go from right to left. So you can actually start here if you want to. Start with the 8 plus 7, that's 15. And see, by writing it that way, that is carrying the 1 over to the next column, the tens column. And then you do 60 plus 50, and then you do your 500 plus your 700. Either way, you still get the same answer. And you can go right to left, or you can go left to right, whichever one you like better. But it's a really nice strategy. It kind of breaks it down into 3 small problems. It makes it easier to add. So let's try this one. And we could do left to right, or we can do right to left. It really doesn't matter. Y'all can do it whichever way you want. I'm going to go left to right. So 800 plus 300 is going to be 1100. So again, that's 800 plus 300. And then we're going to do 20 plus 30. That's going to give us 50. And then we're going to do 5 plus 7, which is going to give us 12. So I'm just writing out on the side how we got these. And then when you add, you get a 2, 6, 1, 1. So 1162 would be your final answer for that one. Again, if you would prefer to do this right to left, you can do it that way. Just show me, how you did it so that I could follow your work. Now with the lattice algorithm, oh sorry, y'all couldn't see that the whole time I was writing it. Sorry. Now you can see it. All right, the lattice algorithm is really a different way to do this. And again, this may not work for your brain, but it might work for somebody's brain out there. Like somebody might prefer to do addition this way. So it's just good to have a lot of tricks in your bag as a teacher, So with the lattice algorithm, what you do is you draw a little box under each column. So in your 1s column, your 10s column, your hundreds column. And then we cut them in half with these diagonals. And what the diagonals are going to do is you're going to give you 2 digits. So when you add 2 single digits, you will either get a single digit or a double digit number. It can't be bigger than that. So we're basically setting up where we could do double digits. So when we add 2 plus 5, we get 7. So that's just a single digit. So you put the 7 here. You can put a 0 there if you want to, or you can just leave it blank, but it's a 0. So 2 plus 5 is 7. Now 8 plus 7, that's 15, so you write it split apart like that, 1, 5, 15. And 4 plus 1 is 5, so that's just a single digit, so it goes down in the bottom. And then what you do is you extend the diagonals and you group together and add the numbers that are in the diagonals. So when we get this first diagonal here, that's just a 7. The next diagonal is 0 plus 5, which is 5. The next diagonal is 1 plus 5, which is 6. And you get an answer of 657. So what happened? Well, 2 plus 5 is 7. The 8 plus 7 is the 5, and the 1 gets carried. And by putting it in this diagonal, you see that right there? That's the 1 and the 5 that make the 6. That's the 1 getting carried. So that's how the lattice method works. It's a really nice method for some people. Not everybody likes it, but as a teacher, like I said, you want to have a bunch of different tricks in your bag. And it works with really large numbers too. So 4 plus 1 is 5. So put a 0, then a 5. 5 plus 7 is 12. 2 plus 4 is 6. 9 plus 6 is 15. So it breaks it down into these nice, small, little, more manageable problems. Extend your diagonals, and then we're going to group up what's in the diagonals. So we have a 5, a 0 and a 2, that makes 2, a 1 and a 6, that makes 7, a 0 and a 5, that's a 5, and then you have a 1. So this one ends up being 15,725. So the ones get carried because of the way that we angle the diagonals, and that's how the lattice algorithm works.